Hey everyone, my name is Ryan. I'm a rising senior at Monte Vista High School, and this is my Milestone 1 video for my project, the shoulder rehabilitation device. And so for the first milestone, I wanted to successfully for my computer to detect my Arduino Nano, and for my Arduino to be able to record data through my shoulder movements, and using that data to create an actual machine learning model, and we can actually to be able to deploy it in the terminal to show how powerful and how accurate this machine model is. So my project, like I said, was the shoulder rehabilitation device. I wanted this device to be able to detect different shoulder movements, such as going to the left, going to the right, going to the ceiling, or staying idle, in order to help those who've suffered from rotator cuff injuries to be able to recover full mobility of their shoulder. So for milestone 1, this is exactly what I did. Through some troubleshooting process in which the Arduino's firmware was not completely updated, I downloaded several software such as Arduino CLI, Edge Impulse CLI, and Brew, and used a terminal app to successfully update the firmware of my Arduino for it to be able to successfully be detected by the computer. And then after that, the first step was to record the data. So I strapped the Arduino onto my arm near my shoulder, and then started recording the data using the Edge Impulse website, which basically allows you to train your own machine learning models. So I recorded 1 minute of data for my shoulder moving to the right, 1 minute of left, 1 minute of going to the ceiling, and 1 minute of idle. And then after each of those rotations being collected and monitored by Edge Impulse, I went into each of the minute of data and split the sample up to around maybe 30 to 40 times per minute. And so what that basically does is I manually go and select where the rotations actually are, so the machine can learn what actually is a rotation and what is just like noise or like accidental movements that you don't want to be recorded in your data. So as you can see from here, these are all of my data sets that I recorded. There ended up being around 132 of them because of the 4 I split them into a lot of different sections. And then as you can see right now, I have an 80-20 split, meaning that 80% of my data is in my validation set, while 20% of my data is in my training set. And this is so my machine learning model is more accurate. It doesn't only just perform in one set, which would be not ideal. And so after I collected all my data, I came to this tab in order to select which axis that I want my machine learning model to detect. And that is the longitude and latitude axis. So I selected that. And then after a lot of graph compiling, it finally gave me this model. And basically telling me that my model was 85% accurate. So 85% of the time, the results will be accurate to match the motions I was doing. And so for here, you can see all the green text boxes, meaning that when I was doing a certain motion, the machine was able to detect the correct motion. And so it's 85% accurate. And since this is just the first rendition of my milestone of my project, this will improve up to hopefully around 95% by the time I reach milestone 3. And then I will show you guys a demo of the data it collects when I do the motions. So this is a terminal app, and when I type the command edge impulse run impulse, it basically runs whatever data I have on this Arduino board. So it displays it. So as you can see here, it's just compiling the data. Starting. Okay, as you can see, there are 4 labels: ceiling, idle, left, right. And based on my rotations and movements of my shoulder right now, it will display. So for example, if I hold my hand still like this in the idle position, it should have a higher number reading for the idle label. And obviously it's not 100% accurate, so there will be inaccuracies in other data reading for other labels, but the highest number should be in the idle label. And then when I move my arm to the left, hopefully you should see more of the data centered in the left label, and then more of the data centered in the right label when I move my shoulder right and back. And also when I move my arm to the ceiling. And so again, obviously it's not 100% accurate, but this is where my first milestone is at. Thank you so much. So after this milestone, my next step would be to increase the accuracy of the model by inputting more data, splitting my data more accurately. I also want to create the actual 3D printed box for this Arduino to act as an enclosure, because the end product is to use a Velcro strap to strap onto a 3D printed box to attach to my shoulder, and not using blue duct tape with foam to hold it together. So those are my next steps for milestone 2. Thank you.